Hi, good evening, all of you. My dear students, I am going to discuss the EC solution GATE 2022. So, my dear students, these questions are based on memory. So, maybe some questions may be getting wrong or maybe correct, but 99.99% I have tried my best. These all questions are correct. Okay. My name is Sushil Kumar Shubhan, pass out from IIT Roorkee. I have cleared 3 consecutive times engineering services 2018, 19 and 2020 with All India rank 45. And currently I am working as a assistant director of the Central Electricity Authority under Ministry of the Power, CPES. My dear students, so first of all, I am going to discuss the questions related to analog circuit. So the questions related to analog circuits. Okay. So here are the first questions from your analog circuit. The question is what? The question is for the circuit shown in the figure. So here the question is the circuit shown in the figure. The circuit shown in the figure. Okay. So what will be the maximum and minimum value? Maximum and minimum value of the capacitance. So maximum and minimum value of the capacitance. What will be the maximum and minimum value of the capacitance? As you know that there is a charging and discharging of the capacitance. So this is nothing but your astable multivibrators. Okay. And here the astable multivibrators having the maximum output potential is plus 15 volt and minimum is minus 12 volt. So you have given output potentials of your square wave. And we have to find the capacitor voltage, that is the VC max minus VC minimum potential equal to what? So my dear students, here we have to find first of all VC max value and VC minimum value. Okay. So how you can find VC max value and VC minimum value? So to find the VC max value, let's say output is at plus 15 volt. Why at this is plus 15 volt? Because as you know that the astable multivibrator is nothing but square wave generators. So let's say the square wave is like this one. This is your square wave. Square wave. And for this square wave, the maximum threshold, maximum potential, maximum plus V saturation is what? Plus 15 volt. And minimum is what? Minus 12 volt. So there is a charging and discharging of the capacitors. So let's charge for the positive half cycle. Then another cycle it is let's discharge. Then again it is charge, and this is your discharge. So there is a charging, discharging, charging, discharging of the capacitors. So let's say the maximum potential is what? So this is your VC max potential. Let's say the minimum potential at which starts the charging, this is VC minimum potentials. Okay. As you know that due to virtual ground concept, this V plus potential is equal to V minus potential. So you can say the VC is nothing but the potential across these feedback networks. Now, case 1, first case. Case 1, first case. For V naught equal to positive 15 volt, if V naught is positive 15 volt, then what will happen? For V naught equal to positive 15 volt, D1 becomes forward bias and D2 becomes reverse bias. So D1 is on and D2 is off. Okay, if D1 is on, D2 is off, that circuit looks like this one. This is minus, this is plus, and this is D1 is on, so short circuit. Now only one resistance is here up to ground R. Now this is R, this is open circuit, so this becomes R and this is R. Now output potential is what? Plus 15 volt. let's say this is capacitance, and this capacitance value is nothing but VC maximum value, and this is your feedback resistance is R resistance. Now, my dear students, let's say this potential is what? VC max potentials. Now apply here. So VC max becomes, this is apply just one, because the input current of op-amp is what? 0. So VC max becomes R upon R plus, this is on series, so this is 2R into plus 15 volt, and you will get this is plus 5 volt. Now on the similar way, case 2, if you apply the case 2, then what will happen? VC minimum for case 2. So just write down this one. Just write down. I hope so. Okay. Now case 2. For case 2, for V naught equal to what? For V naught equal to minus 12 volt. So my dear students, let's say this is for minus 12 volt. So when V naught becomes minus 12 volt, then D1 is what? Off, and D2 is on. If D2 is on, this is a short circuit, and this is what? Open circuit. Now this resistance value becomes what? R, and R is what? 2R. So this R and R, this becomes 2R, and it having only one resistance, that is short circuited. So this is only one resistance. Now in this case, your V naught becomes what? This is case 2. Okay, V naught is what? Minus 12 volt. So this VC max becomes VC minimum. This is VC max becomes VC minimum. So VC minimum is equal to 2R upon 2R plus R into minus 12 volt, and this becomes minus 8 volt. So the VC max minus VC min is equal to 5 minus 8, and this becomes your 13 volt. So answer will be 13 volt. So this is one of the best questions asked in your GATE exam. This is one of the best questions from your multi vibrators. Okay. Now come to the next questions. Now question number 2. Now question number 2. So what says the question number 2? Find the R and C. You have given gain and frequency characteristics. This is your op-amp, and you have given the gain versus frequency cutoff. Now gain versus frequency graph you have to give it. Here is 12 dB, here is 9 dB, and at 9 dB the log 10 omega is 3. So this is nothing but this is your 3 dB cutoff frequency. Now you have to find R and C value. Okay. So here input is what? Plus positive terminals. So input is at the plus terminals, that is the positive terminals. So this is non-inverting type of op-amp. Non-inverting type of op-amp. Op-amp. Okay. Now for this non-inverting type of op-amp, the gain is what? 1 plus RF by RI. This becomes 1 plus R upon 1 kilo ohm. This is your gain. Now my dear students, maximum gain is what? You have to give a maximum gain is what? 12 dB. Maximum gain you have to give a what? 12 dB. So this is 20 log 10 A max is equal to 12 dB. Okay. And after solving this value, you will get the A max equal to 10 raised to power 12 by 20. This is 10 raised to power 0.6. And this is approximately equal to 3.98, which is considered as approximate equal to 4. Now, this becomes 1 plus R upon 1 kilo ohm, gain equal to what? 4. So this R equal to 3 kilo ohm. So you have gain equal to what? R equal to what? 3 kilo ohm. So you are getting resistance value, feedback resistance value. This is equal to 3 kilo ohm. Now, my dear students, you have given the 3 dB cutoff frequency. So log 10 omega C cutoff frequency equal to what? 3 radian per second. So omega c, and that is nothing but 3 dB cutoff frequency. Cutoff frequency. This is equal to 10 raised to power 3 radian per second. Okay. Now, what is the omega 3 dB? This makes the RC time constant circuit. Okay. So what's the omega 3 dB? So omega 3 dB is equal to 1 upon RC. Okay. Now this R is what? R, let's say this is R dash into C. R dash into C. Let's say this resistance is R dash. So omega 3 dB is 1 upon R dash into C. So this becomes 10 raised to power 3 upon 1 upon 10 raised to power 3 into C. So C becomes 1 microfarad. So the value of resistance is R equal to 3 kilo ohm and the C equal to 1 microfarad. This is the right questions. So this is the one of the best questions asked in your GATE exam, 2 marks. So this is one of the best question, my dear students. This is one of the best questions. Okay, got it? Chaliye. So this is the R and C value. Just write down all questions. Just write down solution, or you can take the screenshot. Now, my dear students, I'm going to discuss next question. That is question number 3. These are the memory-based questions. Now, question number 3. What says the question number 3? You have given the mobility because this is your CMOS. It is nothing but your CMOS. Okay, just write just like this one. This is your PMOS. As you know that the combination of PMOS and the CMOS NMOS is called what? CMOS. So this is the combination of, this is called NMOS. This is your PMOS and this is your V naught. Okay. For the NMOS, W by L, and you have to give a what? This is 1. And this is W by LP, you have to give a what? This is 5. And the VTHN equal to what? 1 volt. And VTHP, you have to give a minus 1 volt. Okay, what value? So this is 1 volt and minus 1 volt. You have to give a mobility of electrons is 300 centimeter square per volt second. And you have to give a μp equal to 40 centimeter square per volt second. Okay. So for this CMOS, we have to find the value of V naught. So we have to find the value of V naught if both PMOS, that is C oxide of NMOS, is equal to C oxide of PMOS, both having the same value. Okay. So my dear student, in this question, you have to give the oxide capacitance of NMOS is equal to oxide capacitance of PMOS. Now you have to find what is the value of V naught. My dear students, as you know that whatever your current, IDS current of NMOS is same as it is IDS current of what? PMOS. Because the gate current equal to what? 0. Inside the CMOS or inside the any MOSFET, as you know that the gate current is what? 0. So if your gate current is 0, that is the PMOS and NMOS having the both current will be same. Now you have to find how it is operated. It is operated in triode region or it is operated in saturation region. So as you know that for NMOS circuit, for NMOS, if VDS is greater than VGS minus VTH, then saturation. If VDS less than VGS minus VTH, then what? Triode region. For PMOS, if VSD greater than VSG plus VTHP, then saturation. And if VSD is less than VSG plus VTHP, then triode region. Got it? This is triode region. So this is the formula. Okay. Now, my dear students, both regions are operated what? Saturation. Why? Because this is gate is short circuited. So you can say both region is operated in saturation. So you can say here IDS saturation for NMOS current is equal to ideal saturation for PMOS. So both having the same current, NMOS as well as PMOS. So what the NMOS equations? This is mu n C oxide by 2 W by L n VGS. VGS is what? GS V dot. That is V dot minus 1 whole square plus mu P C oxide by 2 W by LP. That is VSG. VSG 4 minus V dot minus 1 whole square. Now just put here W by LP equal to what? 5. This value is 5. C oxide and C oxide is cancel out. Mobility mu n is what? 300. Bpu is 40. Okay. W by L n is equal to what? 1. So after putting these all values, you will get the quadratic equations. You will get the quadratic equation. And the quadratic equation becomes V naught square plus 6V naught minus 15 equal to 0. Okay. I have solved here. So V naught square plus 6V naught minus 15 equal to 0. And after solving this value, you will get V naught equal to 1.89 volt and another V naught equal to minus 7.9 volt. Okay. So V naught should be what? V naught should be always from 0 to 4 volt, not greater than 4 volt, not below the 0 volt. So what will be the approximate answer? So approximate answer is 1.89 volt, or sometimes you can write 1.9 volt is the right answer. So this is the one of the best questions from your analog. Okay. Now I am going to discuss next question. Just take the screenshot, write all the questions. Okay. These all questions, guys, based on the memory. Okay. Maybe some parameter may be changed, but 99.9% the questions will be same. Now question number 4. The question number 4 says that you have to give this circuit, okay, VI for a small signals. Find the VA by VB. We have to find VA by VB for a small signals. If we want to calculate the VA by VB for a small signals, for a small signal analysis, so just DC source becomes 0. DC source is 0, so this will be ground and this will be short circuited. Now AC circuit becomes, so first of all draw the AC circuit. So the AC circuit is just like this is VI, this is ground, and this is 2 kilo ohm, this is VB, and up to ground this is 4 kilo ohm, and this potential is VA. So my dear students, we have to find VA by VB. So we have to find VA by VB equal to what? So we have to calculate VA by VB. What is the potential VA upon VB? So how you can calculate? First of all, draw its AC circuit. So this is your gate. This is source terminal plus minus open circuit. Now this is 2 kilo ohm, and this potential is what? VB. Now this becomes GM into VGS, and this is your 4 kilo ohm. Now this potential is VA. Now this is your VI. So what's the VA? Just write along this direction, this is GM into VGS. So along this direction is minus GM into VGS. So the drop across the 4 kilo ohm resistance is minus GM into VGS into 4 kilo ohm resistance. Now what becomes VB? VB is just this current is flowing across this one. So thus the drop across the 2 kilo ohm resistance is GM into VGS into 2 kilo ohm. So VA by VB equal to what? Minus 2. Just divide and you will get the answer. So answer will be minus 2. So minus 2 is your right answer. Got it? So this is the questions related to your A small signal analysis. Okay, a small signal analysis. Now, next question. This is question number 5. So here are the questions from analog circuit. This is question number 5. This is the repeated type of questions. I think so. Same type of question asked in 2007, 2001. Okay. The question is like that. You have to give it the op-amp minus plus. This is 2 kilo ohm resistor. This is 1 microfarad capacitor. This is the V input circuit. This is the RF. This is 1 kilo ohm resistance, and you have to give it the V naught potential. You have to VI input. So find the 3 dB cutoff frequency and what is the types of filter. Dear students, as you know that this is the differentiator circuit. Which circuit? Differentiator circuit. And differentiator circuit, as you know that what is high pass filter. Okay, this is the first way. Second method, just put the frequency. X equal to what? 1 upon j omega 2 pi f into c. If f equal to 0, then xc tends to infinity. If xc tends to infinity, then I equal to what? 0. The current input current I equal to what? 0. If f equal to infinity, then xc tends to 0. Then I equal to what? Infinity. It means high amount of current is flowing. If f tends to infinity, it means it will attenuate low frequency. Why attenuate low frequency? Because this becomes open circuit and pass the high frequency. So the frequency and gain, if you draw the characteristic, then it is your high pass filter and having the cutoff frequency. So the 3 dB cutoff frequency, 3 dB cutoff frequency is what? F equal to 1 upon 2 pi R into C. Let's say this is your R1, this is your R2. So this is R1 into C. So the omega equal to what? 1 upon R1C radian per second. Just put these values. 1 upon R1 is what? 2 into 10 raised to power 3 into 10 raised to power minus 6. And you will get this is 10 raised to power 3 by 2. And this is equal to 0.5 into 10 raised to power 3. So this is nothing but your 500 radian per second. Okay. So this is your right answer. 500 radian per second. So the types of filter is what? High pass filter, and the cutoff frequency in radian per second is what? 500 radian per second. If you find out in the terms of hertz, then in terms of hertz is what? You can calculate in terms of hertz. F3 dB equal to, this is 500 upon 2 pi. What will be? This is your 500 upon 2 pi hertz. And this is your right answer. This is your right answer. Got it? So this is your right answer, my dear students. Okay. Now I'm going to discuss next one. That is the next topic. Now, next question is question number 6. The question is a long channel and MOSFET. You have to give it a long channel and MOSFET. Okay, long channel as and MOSFET you have to give it having L equal to 10 micrometer and the width equal to 100 micrometer. You have to give it mu into C oxide. VT you have to give it VGS equal to 2 minus sine 2t volt. VDS equal to 1 volt. Then find the IDS maximum. My dear students, you have to give it VGS equal to 2 minus sine 2t volt. Okay. If you draw these equations, sine 2t having the maximum value is what? 1 and minimum value is minus 1. So maximum value is what? Minimum value is minus 1. So when you put this minus 1 value, so VGS max becomes what? 3 volt. And VGS minimum becomes what? 1 volt. Now we have to find IDS maximum. So first of all, we have to find This is operated in which region? Triode region or saturation region? For saturation region, what becomes saturation? VSDS is greater than equal to VGS minus VTH. For triode region, VDS less than VGS minus VTH. My dear students, if you find the VGS maximum minus VTH is what? 1. So this is 3 minus 2. Sorry, 3 minus 1. And this is equal to what? 2. 2, which is greater than what? VDS. It means satisfy these conditions. Okay. It means MOSFET operate in what? Which region? Triode region. So MOSFET operate in triode region. Now the drain equations IDS becomes IDS maximum. This is mu n C oxide W by Ln. This is VGS minus VTH into VDS minus half VDS square. So this becomes your 10 to the power minus 3. W by Ln, this is your 10. VGS maximum. So this becomes your 3 minus 1 into 1 minus half into 1 square. And after solving, you will get the answer is, just solve it, and you will get the answer is 15 milliampere. So answer is 15 milliampere. Okay. So this is the analog circuit. Now I'm going to discuss next part. That is the next questions. So, my dear students, now I'm going to discuss EDC part. Now in EDC part, the first question is very, very important, very good questions from the EDC is, for a non-degenerate semiconductor, you have to give a non-degenerate semiconductor having NT equal to 10 to the power 16 per centimeter cube. So you have to give an NT equal to 10 to the power 16 per centimeter cube. For NT equal to 10 to the power 16 per centimeter cube, you have given the EC minus EF equal to 200 millivolt. And you have to give the thermal voltage is 26 millivolt. Okay. For silicon, Ni you have to give it 10 to the power 10 centimeter cube. For N equal to 0.5 into 10 to the power per centimeter cube, 10 to the power 16 per centimeter cube, what is the value of EC minus EFN? इसका value क्या होगा? My dear students, as you know that this is the thermal Fermi level. This is EV. This is EF. This is your EC. Now, for N-type semiconductor, as you know that N equal to NC e raised to power minus EC minus EF upon KT. Okay. Now here N is what? ND. Now case 1. First case. For ND equal to 10 to the power 16 per centimeter cube. अगर ND का वैल्यू है कितना 10 to the power 16 per centimeter cube. So if ND equal to 10 to the power 16 per centimeter cube, then in that case EC minus EFN equal to what? This is 200 milli electron volt. Okay, 200 milli electron volt. If case 2, for ND equal to 0.5 into 10 to the power 16 per centimeter cube, then EC minus EFN equal to what? This is the questions. So just put up here, because there is no any change in temperature, so NC is what? NC is constant. Okay, NC is constant. So EC minus EFN equal to KT ln. This is NC upon ND. Let's say this is ND1. Let's say this is ND1, this is ND2, and this is your 1. Now EC minus EFN2, we have to find. So this is KT ln NC upon ND2. So just equation first minus equation 2, you will get this is 200 milli electron volt minus EC minus EF2, okay, is equal to KT ln. This is your NC upon ND1 minus KT ln NC upon ND2. So guys, this is ln A minus ln B. So just solve it. This is 200 milli electron volt minus EC minus EF2 is equal to KT ln. This becomes ND2 upon ND1. And while putting this value, ND1, this is ND2, KT. KT by Q equal to what? 26 millivolt. So KT equal to what? 0.026 electron volt. Okay. So just put these all values and you will get this is minus 18 milli electron volt. So EC minus EF2 is what? EC minus EF2 is equal to 218 milli electron volt. So answer will be 218 milli electron volt. Got it? So just put these all values. Which value? Just put this is KT equal to 0.026 milli electron volt. ND1 is 10 raised to power 16 and ND2 is 0.5 into 10 raised to power 16. You will get this answer. Got it? This is one of the best question from your EDC, electronics devices. Just take the screenshot. Now come to the next question. The next question is very, very important, very good questions. An ideal MOS capacitor. You have to give a MOS capacitor. As you know that in the case of MOSFET, this is N plus, this is N plus, okay, and this from the silicon, and this is nothing but positive, negative. This is your MOS capacitance. As you know that this is T oxide, okay, already you know. So an ideal MOS capacitor, P-type substrate. So you have to give a P-type substrate. The MOS capacitor is under strong inversion with Vg equal to 2 volt. You have to give us this is gate voltage Vg equal to 2 volt. So whenever your gate potential Vg applied 2 volt, there is a strong inversion. That is P-type substrate converted into N-type, a strong inversion. And the corresponding inversion charge density, you have to give us the charge density is 2.2 microcoulomb per centimeter square. Assume C oxide is 1.7 microfarad per centimeter square. So for Vg equal to 4 volt, the value of inversion charge density is what? When C oxide is this, Vg equal to this, then charge density is this. So when Vg becomes 4 volt, what is the charge density? This is the question. Okay. Now, how you can solve this question? My dear students, as you know that the charge equal to what? Charge equal to capacitance into potential, right? That is Q equal to CV. Basic formula. So the induced charge is what? C oxide equal to Vg minus Vth. So Q induced upon C oxide Vg minus Vth. So the Vth equal to Vg minus Q inside upon C oxide. So for the first case what becomes? Just put this first case value Vg equal to 2 volt. So 2 volt minus Q is equal to what? 2.2 microcoulomb per centimeter square. C oxide is 1.7 microfarad per centimeter square. This is cancel out. Micro is cancel out. Now solve this value. This becomes 0.706 volt. Okay. Now for Vg equal to 4 volt. If you put Vg equal to 4 volt, then Q induced is what? This is C oxide Vg minus Vth. So this becomes your 1.7 microfarad. This is 10 raised to power minus 6 up 4 minus VTH is what? VTH. Now VTH becomes 0.706. Just put these all values and you will get this is 5.6 microcoulomb per centimeter square. So answer will be approximately 5.6 microcoulomb per centimeter square. So this is your right answer. So this is the second question from your EDC. One of the best questions. This is one of the best questions asked in your GATE exams. Okay. Now come to the next question, my dear students. Just take the screenshot. You will get that. Okay. So got it. Now next question. Third question. The question is, for p-type semiconductor, you have to give a p-type semiconductor. Okay, p-type semiconductor. So majority is what? Majority charge carrier is what? Holes. Minority is electrons. Okay, minority is electrons. You have given Ni equal to 10 raised to power 10 per centimeter cube. Illuminated by laser at the left end. If you illuminated by laser at the left end, then change in carrier is what? Change in carrier of what? Minority charge carrier. Why minority charge carrier? Because due to law of continuity equations. So continuity, what says the continuity equations? If there is change in the carrier, then significant change in the carrier over the minority charge carrier, not the majority charge carrier. Got it? So there is significant change in carriers of the minority charge carriers. So my dear students, as you know that in p-type semiconductor, the minority charge carrier is what? Minority charge carrier is your electrons. So there is change in the electrons. Now, at x equal to 0, you have given 10 raised to power 14 per centimeter cube. You have given the diffusion length Ln. You have also given the diffusion length for holes is Lp. So find the concentration at x equal to 2 micrometer. Very simple questions. As you know that n x equal to n0 e raised to power minus x upon ln. Okay, due to electrons. This is the concentration equations. Okay, so n at x equal to what? 2 micrometer. And not you have to give an not value is approximately what? 10 raised to power 14. So this is 10 raised to power 14 e raised to power minus x. X is 2 micrometer upon ln is 2 micrometer. Just solve it. You will get approximately this is e raised to power minus 1 into 10 raised to power 14. So approximately this is 3.6 into 10 raised to power 30 per centimeter cube. So this is the concentration at 2 micrometer. Okay, so this is your right answer. Got it? This is your right answer. So these are the questions from your EDC. Now I am going to discuss next part. Now control system. Now this is one of the best questions in the control system. The question is the Nyquist plot for a system. If you have given the system having the Nyquist plot for GS k equal to 1 is equal to this one, the Nyquist plot. Now let's say this is GS having the k upon some pole locations, okay, and some zero locations. Now when k equal to 1, you have given the Nyquist plot. So we have to find for k equal to 2, what will be the pole location? What are the poles? That is the number of poles on right hand side. So what are the number of poles on right hand side for k equal to 2? By the students, as you know that this is nothing but your what? Nyquist plot. Okay, got it? This is Nyquist plot. You have to give it the Nyquist plot. This is your Nyquist plot. You have to give it. Now for this Nyquist plot, this is your Nyquist plot. This is your clockwise, this anti-clockwise, and you have given this is minus 1 J0 point. This is 0. Let's say 0.8 times of k. Okay, and this is your 0.4 times of k. My dear students, if k equal to 1, if you put k equal to 1, then this point is what? 0.8. But if you put k equal to 2, then this becomes what? This becomes 1.6 values, and this becomes what? 0.8 values for k equal to 2. Now for k equal to 2, you have given p plus equal to 0. P plus equal to 0. And as we know that n equal to p plus minus z plus. So if you having p plus equal to 0, now for k equal to 2, this becomes 1.6 value. Now if this becomes 1.6, this is your 0.8, this is 1.6. So minus 1 j0 point lie on this region. If minus 1 j0 point lie on this region, then how much times it including? 1 times clockwise and another 1 times clockwise. So 2 times including clockwise directions. So n becomes minus 2. So n becomes minus 2. Why n equal to minus 2? Because for k equal to 2, if put this k equal to 2, this becomes 1.6. And 1.6 is the greater than 1. So minus 1 j0 point lie at this point. And if minus 1 j0 point lie at this point, this is your clockwise encirclement. This is also clockwise encirclement. So n becomes minus 2. So here n becomes minus 2. So this minus 2 equal to 0 minus z plus. So z plus becomes 2. It means what? This z plus shows that having 2 poles on right hand side of closed loop control systems. Okay, so that is the how much poles on right hand side? 2 poles. So answer will be 2 poles, and these 2 poles shows the system is what? Unstable system. So if asked in this question, system is stable or unstable, that system becomes unstable systems, not the stable systems. Got it? Now I'm going to discuss the next questions. Just take the screenshot. That is one of the best questions. In this question, PS, this is the polynomial. You have to give us this polynomial. PS has all roots on the imaginary axis. The question asked here, what is the range of k? What is the range of k so that this polynomial have all roots on j omega axis? All roots on j omega axis. Okay, that is the imaginary axis. Then what will be the conditions for k? What is the range of k? My dear students, just write this is s to the power 4, s to the power 3, s to the power 2, s to the power 1, s to the power 0. Now this becomes 1, and this becomes 5. This becomes 4 plus k. Now this becomes 0. This is 0. Okay, this is 0. Now polynomial having ps equal to what? S to the power 4 plus this is 5s square plus 4 plus k. Now differentiate it. dps to the power ds. This becomes your 4s cube plus 10s. So this is your 4 and this is your 10. Now solve this value. So this becomes 20 minus 10. This is 10 divided by 4. 10 divided by 4. This is this into this minus this divided by this. So this becomes 4 plus k. Now this part is 416 plus 4k minus 100 by 4, and this 100 by 4 is 25. 25 divided by 10 by 4, and this plus 4 plus k. Now for all roots on j omega axis, this should be positive. This should be positive. Okay, so this should be positive. So k plus 4 should be positive. So k is greater than minus 4. Okay, this should also be positive. Okay, this should also be positive. Why this is, should also be positive? Because there is a formation of auxiliary equation here, s to the power 4 auxiliary equations. So this should be also greater than or equal to 0. Now this becomes 16 plus 4k minus 25 greater than or equal to 0. This is 4k minus 9 greater than or equal to 0. So k becomes greater than 9 by 4. Okay, got it? So this is your k is greater than 9 by 4. Okay. So k is greater than 9 by 4, k is greater than here minus 4. Okay. No, no, no. This 100 by 4. Actually, this becomes minus, this is plus. So this is your minus, this is plus. So k becomes less than equal to 9 by 4. So what is the range of k? K greater than minus 4, but less than equal to 9 by 4. So answer will be k greater than minus 4, but less than equal to 9 by 4. Got it? Again, I will be repeating. If you are not comfortable, then again I am going to repeat these equations. Okay, don't worry about that. Actually, this is your this minus this minus this minus this. So this is your 25 minus this is 16 minus 4k divided by 10 by 4. Okay, so this should be greater than 0. Okay, because this is greater than 0, that greater than equal to, if this is equal to or greater than 0, then this auxiliary, this form the auxiliary equations, and this is also form the auxiliary equations, and having the two repeating roots in the s ka power 4 and having s ka power 2. So there is a repeating roots in s ka power 2 and repeating roots in s ka power 4. So this becomes 0. So the first condition is 4 plus k should be greater than 0. Second condition is what? 9 minus 4k should be greater than or equal to 0. So k is less than 9 by 4. Here k is greater than minus 4. So k is greater than minus 4 but less than 9 by 4. So this is your range of the k. Got it? Now I am going to discuss next question. The next question is very simple question, very, very simple questions. Okay. You have to given this one your root locus. You have given the root locus. So which may be your transfer functions. My dear students, this is k equal to infinity, 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 this is k equal to infinity. How many asymptotes? Number of asymptotes equal to 5. So here number of asymptotes equal to 5, and as you know that number of asymptotes equal to what? Number of poles minus number of zeros. Okay, so here 2 poles, which is not possible. Here 5 poles, but not at equal to 1. This is not possible. This is 6 poles, not possible. So answer only is B options. So B is your right options. Very simple question. Very, very simple questions. Now come to the next question. The question is, if RT equal to 0, if RT equal to 0, E of t equal to RT minus Y of t, then find the steady state error for unit step disturbance. Unit step disturbance. My dear students, if this is unit step disturbance, then circuit becomes your, if RT equal to 0, then this is your 0. Now your circuit becomes, this is your E of S basically. This becomes D of S. And your circuit is looks like this is your looks like. Now feedback becomes minus 10. Okay, feedback becomes minus 10. This is 1 upon S into S plus 10, and this is your, got it? This is your C of S, or you can say Y of S. Okay, so as you know that ES upon DS is what? If you calculate this value, then what you will get ES by DS value. Okay, so ES upon DS, if this is your error function ES, let's say this is your G1S, let's say this is G2S. So you can write here this is G1S, this is your ES. So ES upon DS equal to, this is your minus G1S upon 1 plus G1 s into G2 s. Just put this value minus 1 upon s into s plus 10. This is 1 plus 1 upon s into s plus 10. And here feedback is 10, negative feedback. So after solving, this becomes es upon ds. ds is disturbance is equal to minus 1 upon s square plus 10s plus 10. This is the disturbance. So now for unit disturbance, ds becomes what? 1 by s. So steady state error is limit t tending to infinity e of t. You can write here limit s tending to 0 s into ess. Just put this value. Limit s tending to 0 s into e of s is ds is 1 by s. So this is 1 by s minus 1 upon s square plus 10s plus 10. After solving this value, you will get minus 0.1. So answer is minus 0.1. S is cancel out. Just put s tending to 0. Got it? So for unit state disturbance, the steady state error becomes minus 0.1. Got it? This is your ES upon RS value. Got it? Okay. I hope so clear. Or you can say just GS upon 1 plus GS. Okay. So answer is minus 0.1. Now next question. Next question is very important questions. You have given G1s and you have given G2s, two transfer functions. You have given G1s equal to what? 10 upon s square plus s plus 1. So as you know that 2 zeta omega n is what? 1. Omega n is what? So zeta is 1 by 2. So let's say zeta 1 is 1 by 2. Now G2s, you have given 10 upon s square plus root 10s plus 10. So this is 2 zeta 2 omega n equal to under root 10. Omega n is what? Omega n square is 10. So omega n is under root 10. So again 2 zeta 2 under root 10 equal to under root 10. Cancel out. So zeta 2 becomes 1 by 2. Here zeta 1 is 1 by 2, zeta 2 is also 1 by 2. Now from the options, percentage of NP for both system is same. As you know that NP equal to what? E raised to power minus zeta pi under root 1 minus zeta square. My dear students, here omega 1 is 1. Here omega 2 is what? Under 210 radian per second. Here omega 1 is not equal to omega 2, but zeta 1 is equal to zeta 2. So damping ratio is same, but the frequency is not same. So if frequency is not same, the second question is what? A steady state output will be same for both systems, not possible. Omega d same, not possible. A steady is not possible. So only one answer is percentage of NP. Why? Because the peak overshoot is only depends on zeta, damping ratio. Here peak overshoot only depends on zeta. That is your damping ratio. Get it? So answer will be A options. Now next question. Now next question from your network. Question is, you have given the V1 potential, this is V2 potential, this is ground. We have to find the value of current I. So you can find out this value of current I. How you can find the value of current I? If you separate this another equations, okay, just kept in mind this V1 by V2, okay. So here we apply the KCL, V1 by 2 plus V1 minus 3 upon 1 plus V1 minus V2 upon 2. Got it? Equal to 0. Solve this one. So this is your 2 V1 by 2. Okay. So this is 2. So V1 plus 2V1 minus 6 plus V1 minus V2 equal to 0. And this equation becomes 2V1, sorry, 3 and 4. This is 4v1 minus v2 equal to 6. This is equation number 1. Now write second equation. v2 by 1 plus v2 minus 3 by 2 plus v2 minus v1 by 2 equal to 0. Total outgoing current equal to 0. Here write the equation. That becomes 2v2 plus v2 minus 3 plus v2 minus v1 equal to 0. Right, becomes your 4v2 minus v1 equal to 3. This is equation number 2. Now solve the equation number 1 and 2. You will get I value. Okay. So 4v1, just you can write here 16v2 minus 4v1 equal to 12. So this is 4v1 you can just add them. Now this becomes your 15v2 equal to 18. So v2 becomes 18 upon 15, and this is your 6 by 5 volt. Okay. So v1 equal to 4v2. This is 6 by 5 minus 3. So again, this is 24 minus 15 divided by 5, and this is your 6 by 5 volt. So here v1 equal to v2. Okay. So I current equal to what? 0. Now come to the next. No. This is 24 by 5, 24 by 5 minus 3. So 24 minus 15, this becomes 9 by 5. Okay, here 9 by 5. 9 by 5. So what is the value of I? I is v1 minus v2 divided by 2. So this becomes v1 is 9 by 5 minus 6 by 5 divided by 2. And you will get this is 3 by 0.3 ampere. So answer will be 0.3 ampere. Now come to the next question. You have to, what is the value of I? So how you can find the value of I? This is 1 milliampere. So this is your 1 milliampere current. Now this is, what is the value of I? So just write this is I current. Just write the case here. So 5 equal to 2 of I plus 2 of I plus 1. Now this becomes 5 equal to 4I plus 2. So I becomes 3 by 4 milliampere. And answer will be 0.75 milliampere. This is 1 marks question. Very simple question. Now come to the next question. Next question is one of the best question. You have to give an I of t. This is the graph of I of t. You have to give it. Okay. This is your side of t. So the Z element is what? What is the Z? Inductance, capacitance. If it is inductance, then what is the value? My dear student, this is the lagging. This is nothing but your lagging. Okay. If lagging, then what is the element is what? Inductance. If it is lagging, current is lagging, then that element is what? Inductor. So the I can be right here. I can be right here. You can write this is 1 angle 0 degree sinusoidal. So 1 angle 0 degree upon 1 plus J times of XL. J times of XL. So this is your J times of XL. Now the current is what? 1 by root 2. So 1 by root 2 equal to 1 angle 0 degree upon under root 1 square plus XL square. So it now becomes your XL equal to what? 1. So XL equal to 1. So J omega L mod value equal to 1. So omega L equal to 1. Now what's the omega value? Here omega equal to what? 1 radian per second. You have given 1 radian per second. So 1 radian per second equal to 1. So L equal to 1 Henry. So answer will be B options. Very simple questions. Okay. Why? Because sine omega t, you can write here 1 angle 0 degree, because omega equal to 1 radian per second. So in sinusoidal form, this is in the terms of phasor form. So you can write the sinusoidal equation in terms of phasor form. Got it? Is that clear? So I becomes 1 angle 0 degree upon 1 plus j times of action. So omega L equal to 1 and 2. Now next. Next is one of the best question of the network. The question is like this. This is your network, two-port network. Okay. Now for this two-port network, this current is I1, and you have to give her the 10 volt potential. And here the let's say this is A B network. And now this R is variable. Okay. And this current is I2. Now this potential is V2, this potential is V1. Let's say this potential is V1. And this is your A. Now its equivalent circuit is like this is 1 kilo ohm resistance, and this is your 10 volt across the AB. And the variation of V2 and I2. V2 and I2 you have to give it as like this one. This is your V2 and I2. This is your 5 volt. This is 4 volt. This is 4 milliampere. My dear students, at the 4 milliampere, so this is your decaying slope. So when I2 equal to 0, I2 equal to 0, the current is what? The potential is what? 5 volt. So if I2 equal to 0, case 1. If I2 equal to 0, then V2 becomes what? VOC, open circuit potential, open circuit. And VOC is what? 5 volt. Case 2. Okay? Case 2. If this is load is short circuited. When load is short circuited, when V2 becomes 0. So when V2 becomes 0, if you extend this one, then at what current V2 becomes 0? Because at 4 volt, the slope is this one. Okay. Slope is what? Slope is minus 1 by 4. So dV2 upon dI2 slope is minus 1 by 4. Slope is minus 1 by 4. Okay. So at V2, at what potential? At what potential the current, sorry, so V2 becomes 0 at what current? So at what current V2 becomes 0? So this is minus 1 by 4. So you can write here, if ISC, short circuit current, V2 becomes 0. So short circuit current is minus 1 by 4. Okay. Short circuit current is what? 5 upon minus 1 by 4. And this becomes your minus 20 milliampere. So you can write ISC, short circuit current is minus 20 milliampere. But this short circuit current is what? Direction is this one, ISC. Okay. So I2, now this is your minus 20 milliampere. So now through this circuit we have to find I2. So RTH, because this circuit we have to convert into Thevenin's equivalent, VTH and RTH. So VTH is VOC 5 volt and RTH is what? So RTH is VOC upon ISC. This is 5.20 milliampere. And now this becomes your 250 ohm. So this is 250 ohm. Now this becomes your VOC is 5 volt. Now its equivalent circuit is AB, across equivalent circuit is 1 kilo ohm. And this current is 10 volt, and we have to find this I2. So I2 becomes 10 minus 5 upon 1.25 K, and this is your 4 milliampere. So answer will be 4 milliampere. I think so. Yes. So answer is 4 milliampere. So this is your one of the best part, best questions. Now come to the digital. Digital very simple. What is the value of A dot, A1, A2, A3 such that output is C XOR D? Very simple. As you know that if there is A dot, what you can say? A dot C bar D bar plus A1 C bar D plus A2 C D bar, okay, plus A3 into CD. This is your output Y. If you want to get Y equal to C bar D bar plus CD bar, this is C XOR D. Just put here A dot equal to what? 0. A1 equal to 1. A2 equal to 1. Or A3 equal to 0. So this is your right answer. Out of 4 options, this is one of the one options, that is A. Got it? Just write this Buck's table, or you can say directly you can write the Buck's equation. Just put this value, you will get the answer. Because C bar D bar, select the I dot, C bar D, select the I1, CD bar, select the I2, CD, select the A3. Now come to the next question. The next question is one of the best question. Let's say any get D given the output, let's say this is f of AB equal to what? A plus B bar. Let's say any get, this is your get, having A and B, and output is f of AB, which is equal to A plus B bar. For input A and B, which of the following statement correct? If 0 and 1 are available, you have 0 and 1, both are available. Okay, then what is the output? My dear students, if put here f of 0, 0, then this is 0 plus 1, this is 1. If you put this is A into B bar, then this becomes A plus B bar ka bar, this is A plus B, which get or get. If you put A bar B, then this becomes your A bar plus B bar, that is AB ka bar. This is your that get. Okay. If this is your OR gate, this is your that get down. If you are having that gate, then you can easily equivalent to NOR gate. Why? NOR gate is what? Dot plus OR gate. Okay. If you put f of 0 B bar, this is 0 plus B bar, this is your what? NOT gate. It means you can implement which gate? That gate, NOR gate, OR gate, NOT gate. First it AND gate can be implemented. No. AND gate cannot be implemented. NOR gate can be implemented. Yes, NOR gate can be implemented. NAND gate can be implemented. Yes, NAND gate can be implemented. OR gate cannot be implemented. They can be implemented. Okay. So OR gate can be implemented. See, this option is not true. This option is not true. This is your MSQ types of questions. More than one option is correct. So option B and C both are correct. Got it? So here option B and C both are correct. Just put these values because this becomes your NAND gate, this becomes your OR gate, this becomes your NOT gate. Just take the screenshot. Now come to the next. Next question, very easy questions. F of x plus yz is equivalent to. This can be right here x plus y into x plus z. So x plus y into x plus z, this one is correct. Now you can write here, if you simplify this one, this is x1 plus y plus yz. Yes, this becomes x plus yz. So this is your A option, B option also true. Okay, this is your xz, not the yz, xz options. So C, you can write C. No, C is not true. Not true. So A and B is the right option. Just equivalent. Okay. So this option is correct. So A and B is the right options. Now come to the next question. The next question is very important and good questions. This is your 2-bit up counter. Okay. Let's say this is your input. This is applied the clock pulse. Clock pulse. And you have given this is your MSB dot LSB. Be careful. This is your LSB. Okay. Now this LSB is the input of JK flip flop. This is J flip flop. This is K flip flop. Okay. This is Q. This is Q bar. So we have to find the output frequency is what? Here is the input in terms of JK. Let's say this is 2-bit input. JK. My dear students, JK having 4 possible combinations. Okay, 4 possible combinations. If you get LSB equal to 0, output, let's say this is Q0, this is Q1. So there is 4 possible outcomes. If you get LSB equal to 0, for LSB equal to 0, J becomes 0, K also becomes 0. So the next state is equal to previous state. For LSB equal to 1, J becomes 1, K becomes 1. So next state is what? Q1 bar. So there is 2 possibility in this one. There is 2 possibility of this one. Why? Because 2 times becomes 0 and 2 times becomes 1. So there is 2 possibility of Q1 and 2 possibility of Q1 bar. So output will be what? Output will be after 4 times. That is, you can say T output is 4 times of T clock. So F output is what? F naught by 4. The output clock frequency is 0.25 times of F naught. So here in this question, find the output frequency. So output frequency is 0.25 times of F naught. That will be your right answer. So this is your one of the best questions. Now come to the next question. Just take the screenshot. Got it? Now this question is, which is not LTI. LTI, it means linear time invariant system. My dear students, as you know that for LTI system, there should be frequency should be constant. Frequency should be constant. Constant. Why? If there is a input frequency is F for any system, then output frequency should be also F. There is no any change in frequency. Okay. So this is side T. So side T is side of minus T. You can write this minus side of T. So there is no any change in frequency. So this is your LTI system. Side T becomes side of T plus 1. Here also omega 1. So this is your LTI system. Now side T becomes side 2T. There is change in frequency. So this is not LTI. Side T becomes sine square T. Sine square T you can write 1 minus cos 2T divided by 2. So there is change in frequency. So this is not LTI. So not LTI is what? C and D options. Okay. If asked LTI, which one is the linear time invariant system? That this is your S1 and S2. Got it? So this is the basic simple questions. Not too much. Now, this is one of the best questions of the DFT. Okay. Here DFT, as you know that x of n, having the DFT equal to what? X of k. And x of k can be summation running from n equal to 0 to n minus 1. X of n e raised to power minus j 2 pi by n into nk. Okay, this is the DFT equations. You have given x of n. Okay, you have to give an x of n. How much? 3. This is 8 point DFT. 8 point DFT. So n equal to what? 8. yn is defined as having the DFT is y of k. कारण y of k जो है, y of k is DFT of x of n. X of n. Then y of 0 is equal to what? Y of 0 equal to what? Okay. So DFT of x of n is what? X of k. So first of x of k is what? So just write x of k first of. Just 1 minute. I have solved these questions. Okay. So y of k, x of k. So first of all, y of k. First of all, y of k is what? So y of k equal to n times of x of minus k mod of what? N. So y of k becomes n times of x of n minus k. So this becomes 8 times of x of n minus k. So first of all, DFT of x of n becomes what? This becomes 16 0 0 0 8 0 0 0. Now we have to find this DFT. Okay, so this y of k, y of n, inverse DFT becomes 1 by n, summation running from k equal to 0 to n minus 1, y of k, this is e raised to power j 2 pi by n into x of n. My dear students, जब आप इसे put करेंगे, now after putting this value, y of 0 becomes what? Y of 0, so this is x of n and k. Now while put this value y of 0, this becomes 1 by 8 into summation of running from k equal to 0 to 7 x of n. So this is 1 by 8 into summation of running, this is 16 plus 8. This is 16 plus 8, so this is equal to 3. So y of 0 equal to 3. Answer is 3. So this is the questions regarding your DFT point of view. Okay. So answer is 3. And you can solve this question or another way, just like this one. Let's say y1 of n equal to DFT of x of n. This is y1k. Let's say. Now whatever your DFT, just assume this one. Another is y2n. Now y2k becomes DFT of x of n. Just 2 times DFT, right? This is DFT. And you can find the easy way. So this is one of the best question. Y of 0 becomes 3. So answer will be 3. Now next question. This is very simple question. Very simple question. As you know that e raised to power minus a mod of t. What is the Fourier transform? 2a upon a square plus omega square. Just put a equal to 1. You will get mod of t equal to what? This is 2 upon 1 plus omega square. Okay. Now, just t into e raised to power minus mod of t. So this becomes your minus jt, minus d by d omega 2 upon 1 plus omega square. And this becomes your, after solving, this becomes your j 4 omega upon 1 plus omega square whole square. Okay, so t raised to power minus mod of t, this is minus j 4 omega upon 1 plus omega square into whole square. Got it? Now, just apply the duality. As you know that the duality property is what? f of t having the Fourier transform if f of j omega, then f of minus omega 2 pi is having the Fourier transform f of jt. So if omega is replaced by t, then this is 2 pi into f of minus omega. Same procedure is doing here. So this is 2 pi, this is 2 pi, t is replaced with minus omega. So e raised to power minus of omega, then omega is replaced with t. So this is minus jt 1 plus t square whole square into 4. So this is minus 2 pi by minus j4 omega e raised to power minus mod of omega. This is equal to t upon 1 plus t square whole square, and you will get this is cancel out, this is 2 cancel out, so you will get this is pi by j2 omega e raised to power minus mod of omega having t upon 1 plus t square whole square. So answer will be D options. So just apply the duality property, you will get the right answer. Okay. So this is nothing but your based on duality property. It's one of the best questions. Now next question. Just take the screenshot. Now next question is, you have given x1t, you have to give x2t, yt is defined x1t convolved with x2t, then what is the limit t tending to value y of t? Just take the Laplace. As you know that x1t having the Laplace transform is x1s, which is equal to what? 1 upon s plus 2. x2t having the Laplace transform is x2s, which is equal to 1 by s minus e raised to power minus 2s by s. So convolution in time domain is multiplication in frequency domain. So y of s can be right here x1s into x2s. To solve it, 1 upon s plus 2 into 1 upon s into 1 minus e raised to power minus 2s. So this becomes 1 upon s into s plus 2, 1 minus e raised to power minus 2s. This is your y of s. Now, by using final value theorem, as you know that final value theorem is what? If limit t tending to infinity y of t, then this becomes limit s tending to 0 s into y of s. Just put here. So limit s tending to 0 s into y of s. This is s plus 2 1 minus e raised to power minus 2s. S is cancel out. Now this becomes your 1 minus 1 upon 2. This becomes your 0. So answer will be y of t for limit t tending to infinity. This is equal to 0. So steady state value of the output is what? 0. So 0 is the right answer. Okay. So thank you for the watching. I have tried my best, and these all questions based on your memory. Okay. So in the next, I will discuss further the next questions. Okay. So these are the I have covered here EDC, analog, signal and system, digital electronics, and network theory. Thank you so much. Thanks for the watching.